Continuing our series on the 2011 Physics A2 paper from CCEA, Unit 2 Fields and Their Applications, and question 8 is on particle physics. 8a. Pions and kaons are classified as mesons. What is the composition of a meson? And so obviously here we have mesons which are always quark and antiquark in a pair. Part B, consider equation 8.1 which represents beta minus decay. So we have a neutron going to a proton plus an electron plus an antineutrino. Complete table 8.1 with respect to the particles in equation 8.1. Okay, so let's have a look at this table, and we're being asked for properties of the neutron and the proton and the electron and the antineutrino. And the table is specifically telling us that the antineutrino is of the electron type. So we fill in our electron and the anti-electron neutrino. The charges here are meant to be in coulombs, so we need to be careful that we put the proton down as positive 1.6 times 10 to the minus 19 of a coulomb, and the electron down as negative 1.6 times 10 to the minus 19 of a coulomb. Baryon numbers, while the proton here has a +1 baryon number, the neutron is also a baryon, so it gets a +1, but the two leptons here have to get baryon numbers of 0. Likewise, the two baryons have to get lepton numbers of 0, and the important one here is this is an antiparticle, and antileptons will have a lepton number that is -1. Part 2 then. Which, if any, of the quantities charge, baryon number and lepton number must be conserved for any reaction to be possible? If none, write none. And the answer is that all of these properties would need to be conserved. Charge would need to be conserved, baryon number would need to be conserved, and lepton. So all three is the answer. Part C, what is the quark structure for a proton? Well, protons consist of ups and downs, and so do neutrons. So there's one of them that's got 2 ups and a down, and one of them that's got 2 downs and an up. Now what we need to remember, if you're going to do this from scratch, is that the ups have a +2/3 charge, and the downs have a -1/3 charge. So you're just asking yourself which combination of one of these and one of the other would give us a +1 charge belonging to the proton, and you should realize that it's going to be 2 ups and a down that will come to +1 charge, whereas 2 downs and an up will come to 0. So UUD is the proton structure. Part D then, describe beta minus decay in terms of quarks and include the intermediary stage of the virtual particle emitted in the process. So we have a proton, which is UUD, and we have a neutron, which is UDD. So it's really the conversion of this middle quark that is the change from proton to neutron and vice versa in the two types of beta decay. So in the kind that we've had described, we've got a neutron turning to a proton, so we're going this way. So what we've got is a down quark turning to an up quark. Plus something here which then decays itself to the electron and the anti-electron neutrino. So whatever it is, it has to be negative, and so that means it can only be the W minus particle. If the decay was to something that was overall positive, so we've got a neutral particle here and a negative, so this combination is negative. So whatever the virtual particle that we get, it has to be a negative one so that it conserves charge in its own decay. So if we were getting the other type of beta decay, where we're going in the opposite direction here with the proton turning to a neutron plus a positron plus a normal neutrino, we would be decaying to a plus thing here, and that would have to be by the W plus. But in this case, we have to end up with this negative thing, so it has to be by the W minus, decaying to those things. And that's that.